Right, let's have a look at this one. Y equals negative 3 log base 4 of negative x plus 2. Now if we have a look at our form, so in the form y equals a log base r of b x minus h plus k, hopefully, well, let's just write again, y equals negative 3 log base 4 of negative x plus 2. Hopefully you can see that my a value is negative 3 and my b value is negative 1. All right, so now I've got a reflection in my x-axis and in my y-axis. So I remind myself, well, a positive log graph looks like that. So that will help me to figure out what the shape is of this graph that I'm going to be drawing. So I can say a is less than 0, so therefore it is reflected in the x-axis. B is less than 0, therefore it is reflected in the y-axis. And I'm just going to draw myself a little idea of what it's going to look like, because if it's reflected in the x-axis, I'm going to have my tail going up, but if it's reflected in the y-axis, it's going towards the left. So I'm going to have something that looks a bit like that, and that's what I'm kind of expecting to have. Okay, now if I have a look at my horizontal shift, which happens at h, I've got one at x equals negative 2. So I'm going to have a horizontal asymptote at x equals h, and so that means x equals negative 2. All right, now based on the shape of that and the fact that I've got a vertical asymptote, vertical asymptote at x equals negative 2, I am not going to have a y-intercept. So this means that I'm going to have to find another strategic point, as we did with the last one. However, I am going to have an x-intercept. So let's start with our x-intercept. So x-intercept happens when y equals 0. So we have 0 is negative 3 log base 4 of negative x plus 2. I can divide both sides by negative 3. So I have 0 is log base 4 of negative x plus 2. And I can rewrite this in exponential form. So 4 to the 0 is negative x plus 2. And anything in the whole wide world to the power of 0 is 1. So then divide both sides by negative 1. And x will be negative 3. Now remember I said to you we're going to select a strategic point. So let's select a strategic point. And our equation is y is negative 3 log base 4 of negative x plus 2. Remember I said, well, if we can get this thing here to equal my base, then what I've got is I have a log base 4 of 4, or log base a of a, and that would then mean that I have that equal to 1, and it's really easy to find. All right, so how do I get negative x plus 2 to equal positive 4? Well, if x was equal to negative 6 plus 2 is negative 4 times negative 1 is positive 4. So I'm going to let x equal negative 6. Okay, so that means that y is negative 3 log base 4 of negative 6 plus 2, negative 3 log base 4 of 4, and y is negative 3. All right, now I've got 2 points. I have an asymptote, and I know what shape this is going to be. So my asymptote was 3x equals negative 2. wasn't quite straight. It's very far off from my -2. Quite hard to gauge this here. Don't know if it's going to go through. That's at x equals -2. Okay. And my x-intercept is at -3, 0. And my other significant point is at -3, -6. All right, and I know that my shape is going to be something like this. Oops, that went a little bit skew. There we go. Y equals -3 log base 4 of -x plus 2. Now let's have a look at this domain and range. So in this case, the domain goes from -infinity all the way to x equals -2 and not beyond. So -infinity to -2. And my range goes from -infinity to +infinity.